We are given two parallel threads with the linear charge densities lambda and minus lambda, and we need to find the potential and electric field due to this combination of threads. So this is a 3D diagram. So both the threads are going inside the plane, or you can say both are coming outside the plane. So let's say this has a positive charge, this has a negative charge, and let's take a point randomly at a distance r and at an angle theta. So we need to find the potential and field at this point. So our approach here is we are going to find the electric field first, because that would be easier to find because of both the wires we can find electric field. And then by minus E dot dr we shall find the potential. So here let's find the electric field first. So ER is E plus minus E minus. So due to the positive charge, let's say it is E plus, and due to the negative charge, let's say it is E minus, electric field at this point. So difference of that will be the electric field in radial direction, as phi is small. So you can write the actual electric field in radial direction as E plus cos phi minus E minus cos phi. But cos phi is almost 1, so we can write it as E plus minus E minus. Now E plus, due to the positive charge, it is 2k lambda by r, and r is r minus d cos theta by 2. See, if this distance is d between the charges, then this distance is d by 2. And if you drop a perpendicular from here on this, so you can see that if this is r, then this is less than r by this amount, and this amount is d by 2 cos theta. So this distance is r minus d by 2 cos theta. And here you can see again, if you drop a perpendicular from here, this length is greater than r by this amount, and this amount is again d by 2 cos theta. So this distance becomes r plus d by 2 cos theta. So we'll put those values here. So for positive charge, it is 2k lambda by r minus d cos theta by 2, and for negative charge, minus 2k lambda by r plus d cos theta by 2. So simplifying it, again in the denominator we will have r square minus d square cos square theta by 2. So we'll again neglect this because r is much greater than d. And in numerator we will have d cos theta by 2, and d cos theta by 2 will get added up, and we'll get 2k lambda 2d cos theta by r square. You just solve it, you will get this. So this is our E radial. Now potential. So as we were trying to do, we have found the E first in radial direction, and by E dot dr we can now find the potential. So why only ER term? So you can put the theta term also. So ideally dV is minus E dot dr is equal to, so E we can write as ER plus E theta dot dr, and theta and r vector are always perpendicular to each other, so their dot product is going to be 0. So this term becomes ER dot dr, and ER we already calculated, and because they are parallel we'll just put them together. So this becomes 2k lambda d cos theta by r square into dr, and if you put the limits you will get the answer for your potential. So this is the potential at this point. So we have found the potential. Now we need to find the electric field. So we have already found the electric field, but that is in radial direction. We still need to find the electric field in the tangential direction. So for that, because we have found the V now we are again going to do the minus del dot V, minus del V to find the electric field. So we do that. So this component we will not do because we have already found the ER, but we are going to find E theta now. So this part we will do. So E theta, if you put the value of potential here, so except theta everything else is constant. So this will become 2k lambda d by r square times dou by dou theta of cos theta. So that will be sin theta. So this will be the value of E theta. So ER we already found, and E net if you want to find, that will be just root of square of ER plus E theta. Root of ER square plus E theta square, which will give you your answer. So very good problem, lot of things to learn here. So again I'll just recap what we did. So we wanted to find potential and electric field. To find potential, first we found electric field in radial direction. From that we found potential. From potential again we found field, but this time in tangential direction. In radial direction we already have found, so we did not do it again. If you want, you can just try. You can put the value of V here, and if you do this, you will get the same value as this. So E net will finally was the square of ER and E theta.